Welcome back to Bazai. Today, we're embarking on a detailed technical flow of xAI's Grok-3. This cutting-edge AI, fueled by a colossal 100,000 NVIDIA H100 GPUs on the Colossus supercomputer over an astounding 200 million GPU hours, processes your requests through a fascinating and intricate architecture. The process ignites with your user prompt. Grok-3 distinguishes itself by accepting multimodal inputs. You can interact using text, upload images for contextual understanding or analysis, or even provide audio input, offering a significantly more natural and versatile interaction than traditional text-only models. The very first technical step is tokenization. Regardless of whether you've provided text, an image, or audio, Grok-3 breaks down this raw input into a sequence of discrete units called tokens. For text, this involves segmenting words and subword units. For images, this entails extracting key visual features and representing them numerically as tokens. Similarly, audio signals are processed and converted into a sequence of acoustic features, also represented as tokens. This crucial tokenization stage transforms diverse input modalities into a unified, numerical language that the subsequent layers of the model can effectively process. While not directly part of the real-time prompt flow, synthetic data training plays a pivotal role in shaping Grok-3's understanding. During its pre-training phase, Grok-3 was exposed to a massive dataset that was likely augmented with artificially generated examples. This technique enhances the model's ability to interpret a wide range of query structures, understand subtle nuances in language, and resolve potential ambiguities, ultimately leading to a more accurate interpretation of your specific prompt. The core intelligence of Grok-3 resides within its powerful transformer model. This deep learning architecture, celebrated for its exceptional ability to grasp context and long-range dependencies within sequential data, takes the tokenized input as its primary data source. The transformer comprises numerous interconnected layers, featuring self-attention mechanisms and feed-forward neural networks. The self-attention mechanism allows the model to weigh the importance of different tokens within the input sequence relative to each other, effectively capturing the contextual relationships. The feed-forward networks then further process these context-aware representations, extracting increasingly higher-level and more abstract features from the data. The sheer scale of Grok-3's transformer, a direct result of its extensive training, enables it to learn and represent incredibly complex patterns and relationships present in the vast training data. To ensure its responses are not only intelligent but also up-to-date and factually grounded, Grok-3 incorporates deep search. During the processing within the transformer, the model may determine that it requires external, real-time information to provide a comprehensive and accurate answer to your query. In such instances, the core transformer issues a search directive to the dedicated deep search component. This directive contains specific search terms and parameters derived from your prompt and the model's current understanding. Deep search then actively and intelligently queries the vast expanse of the web and the constant stream of information on X, formerly Twitter, retrieving relevant snippets, articles, and posts. This freshly acquired information is then meticulously processed and integrated back into the transformer's internal representations, effectively augmenting the model's knowledge base and allowing it to generate responses that are informed by the latest data. A critical aspect of Grok-3's architecture is its self-correction process. This internal feedback loop is designed to enhance the accuracy, coherence, and reliability of the model's output. After an initial pass of processing and the generation of a preliminary response, Grok-3 likely evaluates its own reasoning steps and the content it has produced. This evaluation might involve techniques such as comparing different potential response pathways, checking for logical inconsistencies within its reasoning, or verifying the alignment of its output with the information retrieved from deep search. Through this iterative internal feedback mechanism, Grok-3 can refine its understanding of the query and iteratively improve the generated response, leading to a more accurate, coherent, and trustworthy answer. Depending on the complexity and specific requirements of your request, Grok-3 can engage specialized processing modes. For intricate queries that demand multi-step reasoning, logical deduction, and problem-solving, Think mode is activated. In this mode, the transformer likely follows instructions to decompose the complex problem into a sequence of smaller, more manageable subproblems. The model then tackles each subproblem individually, potentially utilizing deep search multiple times to gather specific information relevant to each step in the reasoning process. This approach mirrors the way humans often break down challenging tasks into smaller, more solvable parts. For computationally intensive tasks, such as complex simulations, in-depth data analysis, or intricate logical reasoning, Grok-3 can engage big brain mode. This likely involves the allocation of a greater amount of computational resources within the underlying infrastructure and potentially the activation of specific configurations or layers within the transformer architecture that are optimized for handling high-intensity processing demands. Notably, both Think Mode and Big Brain Mode can further leverage the capabilities of Deep Search as needed throughout their respective processing flows to gather additional context or verify information. Finally, Grok-3 delivers its processed information back to you in a multimodal manner, mirroring its input capabilities. The refined information within the model is transformed back into a format that is suitable for your consumption. This can be a textual response, providing a natural language answer to your query. It can also include images, either generated by the model itself or retrieved as relevant supporting information. Furthermore, Grok-3 can deliver its response via audio, offering a more interactive and accessible user experience. In summary, the journey of your prompt through Grok-3 involves a sophisticated and interconnected series of steps: multimodal input, tokenization, leveraging pre-trained knowledge enhanced by synthetic data, deep contextual understanding through a massive transformer model, real-time information retrieval via deep search, an internal self-correction mechanism for enhanced accuracy, specialized processing modes for complex and intensive tasks, and finally, multimodal output delivery. This intricate and powerful architecture is the foundation of Grok-3's anticipated capabilities and versatility in the realm of artificial intelligence. And that concludes our detailed exploration of Grok-3's technical flow. We hope this in-depth explanation has provided you with a comprehensive understanding of its inner workings. If you found this informative, please give us a like and subscribe for more deep dives into the world of AI.